Hello everyone, myself Dr. Awais Ahmed Hussaini, Head of Department, Automation and Robotics Department, Sharad Institute of Technology, College of Engineering, Yadrao. So today we are going to talk about some introductory part of the Newton's law of motion. So you all are aware how that particular Newton's law of the motion is most important as far as that fluid mechanics as well as thermal engineering is to be concerned, and no doubt it is a very fundamentals related with the physics concepts and the engineering concepts. So let us start with the Newton's first law of the motion. The Newton's first law of the motion is totally depends on the concept of the inertia. Okay, it's very basic things. You must know about the what is the inertia force initially. Okay, so according to the Newton's first law of the motion, it states that an object remains at state or in the rest condition or in the motion at a constant speed in a straight line unless and until some external force is applied. So in simple manner we can say that the object will continue to remain at rest, or it can be moved in a straight line or in the constant with the constant velocity unless acted upon some external unbalanced force. Okay, so this means there is no any external force is applied to an object. When the object is stationary condition, then this particular it always remains in a state in rest. When the object is moving, will keep moving with the same speed, in the same direction, with the constant velocity. There are two perspectives. If the body remains as it is, if the second condition is when the body perform its own linear motion, at that time this particular Newton's first law will apply. So it's important to study that particular the concept of the inertia in this case. So as you know that there are certain examples, I will going to explain the different examples of the inertia as well at the end of the Newton's first law of the motion. But before that, the most important thing is that the property of the matter to resist any change in its state of the rest or in the motion is called as the inertia. I repeat, the property of the matter to resist any change in its state of rest or in motion, it is called as the inertia. When the body is in stationary condition, then definitely some inertia force we will apply, and if the body is continuously rolling, if it is moving, then again that inertia force is always with that particular body. So it's very basic thing, and common sense is that if the object is heavy, it has more inertia, right? Harder to change its state of the motion na. So that's why if the object is very heavy, it has a more inertia. Just to take example of the turbine blades and all for that. And if that particular object is light, it has a very less inertia, like that. So for that there are some important examples I already given here. But before that, I just give you some kind of the fundamental things related with the rest and uniform motion are the both natural state of an object. The motion does not require continuous force. Instead, force is only needed to change the motion, that is speed. Okay, so this is the important thing. You just take example of the parked car. The parked car remains as it is till some we will start that particular vehicle, and then it will be move in the forward direction, right? So this is the example of the Newton's first law of the motion. The second is that the ball is continuously rolling. It continuously rolling as it is unless and until some external force will apply and it will stop at the end. Another example is astronauts floating in the space. It remains as it is till that particular situation will arises. Seat belt in the car. That seat belt keep that particular passenger in a stationary condition. If that particular belt is removed, it performs some oscillation. A book on the shelf. The book which is kept in the shelf, it is in the stationary kind of the things, right? If we just pick that particular book, then it's change its position. Then the next is a sled on the snow. Again, it is an important example. A driver of a diving boat, it remains continue its diving unless and until some external force or resistance will happen. Again, that leaves falling from a tree, it is again some examples of that particular Newton's first law of the motion. So here I given some better examples as far as that consideration of the inertia force as well as the Newton's first law of the motion. When a car stops suddenly, the passenger still feel just moving just to and fro, like that is a forward motion, right? Mostly it becomes a forward motion. This is due to the inertia of the motion. This is because of the inertia force. So heavier is the object, inertia is more, and vice versa, like that. Another example is just to take example of the table fan. When you turn off a table fan, blades continue to move for some time even without electricity. It because of the Newton's first law of the motion, and it happens because of the inertia force only. Similar way, just to take example of the turbines which is used in the hydroelectrical power plant. Then you can take example of the blades of the windmill, then the blades of the steam as well as the gas power plant. Once we stop that bombarding that type of the flow of the fluid over the blades, then it still goes moving, and it is totally because of that inertia force. The third example is again, which is very familiar, that is just to take example of one lady. He is just washing their dishes. So dirty dishes remains as it is unless and until that particular woman will just pick it and just apply some force on it. Okay, so it's related with the Newton's first law of the motion, right? So I just move, and now we are going to talk about the Newton's second law of the motion, right? So the Newton's second law of the motion, what is exactly the Newton's second law of the motion? So the Newton's second law of the motion explains how the motion of an object changes when net force is to be applied. It's very simple, that is force is equal to mass into acceleration. If you apply the more force, that particular object will move in the faster direction. If you apply the force at a very less rate, then it will move in the slower direction, like that. Okay, so the Newton's second law of the motion states that it explains related with the acceleration concept, how the motion of an object changes when the net external force is to be applied. Okay, means in simple manner, the rate of change of the momentum is directly proportional to the net force to be applied. Means if you apply more force, that particular object will move in the same rate at a faster rate, and vice versa, like that. Okay, so mathematically we can write that is F is equal to mass into acceleration, because that mass is constant in this particular case, and A stand for that acceleration, and F is nothing but what? Force. Okay, so that force applied is directly proportional to the acceleration, and mass is constant, so F is equal to m into A, like that. The acceleration of an object depends directly on the applied force, I said earlier, and it is totally depends on or it is independently, means it is totally inversely proportional to the mass. Okay, just like the larger the force, greater the acceleration, larger the mass, smaller the acceleration. Okay, if you just move heavier object, then it will move in very slowly, na. Just to take example of that particular pushing a trolley which is having the very heavy mass, then if you apply the force, then it will move in that at a slow rate. If the trolley is empty, then again if you are applying the same force, then it will be move in the forward direction, right? In the similar way. So there are certain examples, just I mentioned here, that pushing a shopping cart, if it is empty and if you apply X amount of the force, then it will be move in the faster direction. If that trolley is full of mass, then if you apply the same force, then that particular the speed of that trolley is less. So similar way, just to take example of the kicking of the soccer ball, if you apply the more force, it will be that soccer ball will move ahead in the forward direction at a fast rate, and vice versa. Driving of a car, if you are just driving a car, if you just accelerate it, okay, but here you just take example of heavier kind of the automobile as well as that passenger, you can take example of the car as well. If you compare the passenger vehicle along with the particular car, then if you accelerate, if you apply the X amount of the force, then that particular car will move faster as compared with the passenger car. Then shooting a basketball is another example. Launching of rocket is a best example of the Newton's second law of the motion. Maximum the thrust is there. That thrust is most important, and that thrust is responsible for that moving that particular rocket in upward direction, right? Then swinging a golf club, pulling a wagon, then pushing a shopping cart again. So these are the basic example of the Newton's second law of the motion. So it's simply the acceleration of an object depends on the mass of the object, and the force is to be applied. So it's directly proportional to the acceleration and inversely proportional to the mass, you can say. So this is all about the Newton's second law of the motion. Now when we are going to talk about the Newton's third law of the motion, it depends on the action and reaction principle. So every action there is an equal and opposite reaction. Every action there is an equal and opposite reaction, right? So the better example is rocket launchers, explaining the gases in the downward direction, because that whatever the after combustion, whatever the gases are there, it will be moved in the downward direction, and that vehicle is propelled in this upward direction. Okay, this is the best example. Just to take example of the hot balloon as well for this particular situation. When we are going to talk about the Newton's third law of the motion, when a body applies a force on another, the second body applies an equal force back on the first body, but in the opposite direction. Keep in mind. Okay, these two forces are called as the action and reaction force, right? They are always act in opposite direction. They act in the different object, never on the same body, which is why they do not cancel with each other. So when we are going to talk about the fundamentals, then simple, the magnitude of the action and reaction forces are equal. It should be equal. The direction of the two forces are in opposite direction. The action and reaction pairs always in the simultaneous. The examples are rocket launchers, rolling of the boat, bouncing a ball, swimming, recoil of the gun. Then if you just move that on the path, then again it becomes an example, better example and simple example of the Newton's third law of the motion. And pushing a wall, if you just apply the force on the wall, then definitely some action will be there, and equally that reaction will becomes from the wall. Then hitting a baseball. These are the basic examples of the Newton first law, second law and third law of the motion. So hence the students, this is a very fundamental and introductory part about the different Newton's laws, that is Newton's first law, Newton's second law and Newton's third law of the motion. And in upcoming videos we are going to discuss about some more these particular laws in the detail. So thank you for the joining.